So this section is all about how extraordinary water is. Here in the Central Valley of California, we are very aware of the need for water. It's the most common and the most important liquid on Earth. There are not a lot of other substances that are present in a liquid form, and you don't find them just laying around very much. Vegetable oil is a liquid, but other than oils, there's gasoline, acetone, alcohol. Not a lot of different substances, though. Pretty much anything you can think of that's a liquid, like milk, is actually an aqueous solution. So we know that water is essential for life. It has a low molar mass, and yet it is a liquid at room temperature, and that's due to hydrogen bonding, extraordinarily strong intermolecular forces which hold it together as a liquid at room temperature. It's the main solvent inside living organisms and in the environment. It has an exceptionally high specific heat capacity, which is what moderates climates, and it expands upon freezing, which is also unusual. And this is the result of water expanding upon freezing. So here we have a nice head of lettuce. Lettuce is, a living plant organism. It's got cells, right? Inside the cells, there's water. If you stick the lettuce in the freezer, or maybe it just got into the part of the refrigerator that's a little too cold, right? I'm sure that's happened to everybody. And the lettuce freezes. Nobody wants to eat this lettuce. Once it thaws out, it's just mush. Because as the water in the cells freezes, it expands and it bursts the cell walls. And yeah, your lettuce is just mush. And that happens to a lot of plants in freezing. This is, annual flowers that we get a good frost and they just all give up and die. They are not hardy, and a temperature of 32 degrees Fahrenheit will cause their cell walls to burst. Other plants can withstand freezing temperatures, but there's other things going on that causes that to happen. So here is a more elaborate graph showing the high boiling point of water. What we've got here is group 4 elements, compounds with hydrogen, and we see that as the period increases, which would be an increase in molar mass, increase in dispersion forces causes the boiling point to rise. This row here is just a nonpolar. These are nonpolar, so they only have dispersion forces. In group, let's see, that was 4. This is group 5 in the yellow. Now these are polar molecules, and so the boiling point is higher. And then we've got group 6 is in the blue, and then group 7. And all of these show a trend of increasing boiling point as you get larger molecules. But these 3 right here are clearly breaking the trends. What do these 3 substances have that the others don't? Hydrogen bonding. You need hydrogen bonded to oxygen, fluorine, or nitrogen. Remember, ET phone home. FON bonded to H. There's oxygen, there's fluorine, there's nitrogen. All of these have unusually high boiling points compared to similar substances. Water pollution is a big issue. Water's necessary, but if it's got too much stuff in it, it doesn't really sustain life. There's 2 kinds of pollution. There's biological contamination and there's chemical contamination. And the way those are treated, they are treated differently. So biological contamination, microorganisms that cause diseases, cholera, hepatitis, dysentery, typhoid, the list just goes on and on and on. These will commonly get into the water when you've got either animal or human waste that's dumped either into bodies of water or near them. So if you've got strawberries that are being raised near a cow pasture and the water runs off from the cow pasture where the cows poop, let's face it, they do. And stuff from the cow pies leaches into the water and can get into the strawberries. And if you don't wash them with fresh water, you can get pretty sick. You can treat this sort of contamination chemically. One treatment that works pretty well is using bleach. Or you can boil the water, which will kill most of those organisms. The other kind of contamination, though, is chemical, and this comes from the runoff. You fertilize your lawn, and it rains, and not all of the fertilizer was used by your grass, and so some of it runs off into the river. Also, household dumping. A lot of times by the drain it says, do not dump, drains to river. Don't dump your extra oil or your antifreeze down the sewer because it goes into the water system. Industrial dumping is also a problem. Most chemical contaminants are non-volatile. They are not alive, so boiling them is not going to get rid of them. In fact, if you boil water that's chemically contaminated and you boil it a long time, you actually reduce the volume and concentrate the contaminants. So yeah, you make it worse. Definitely make it worse. So the only way to get rid of chemical contaminants would be something like reverse osmosis or another sort of a filter or an ion exchange where you're removing the chemical contaminants. Anybody have any questions?